Okay, so in this unit we're going to have a look at Linux and automated security assessment tools. So the key areas that will be covered with inside the CeH certification include a strong understanding of the Linux file structure and directories, some Linux commands, understanding the root user and the user ID and group ID, compiling Linux programs, hacking Linux, securing Linux, rootkits and countermeasures, and automated assessment tools. Okay, so let's have a quick look at the Linux file structure. And what we find is that the top level directory is the / directory or the root directory. So we can have a look at an example here. So in this case we're using vCenter, VMware vCenter, to create our Linux system. So this is Ubuntu. So typically what we do is that we actually open up a terminal and we can actually have a look around. So the top level is /pwd, shows us our present working directory. Okay. There we are. But just put it into full screen. So ls is a command that we use to list the files and folders. So I can see the key folders at the top level here are bin, etc., lib, sbin. We have user, home, boot, media, proc, var, dev, mount, root, and sys. So the key folders that we have are bin. So bin keeps most of our key commands such as ls, change mod and so on. We have dev, and dev gives us access to our device files that allow us to mount devices onto the system. Etc. is where we keep key configuration files. As we'll see, the password file is a good example of this. Mount is where we add our devices such as CD-ROMs onto. User is typically where we have a great deal of documentation, source code and so on. And sbin is where we also have additional commands and daemon processes. And home is where we have our home directory. Okay, so we'll have a quick look around the file system again. Put it into full screen. Okay, so if we go into the bin folder, we'll see in here this is where a good many of our commands are kept. So you can see ping is here, change mod. We have copy, cp. Cat allows us to list a file. Change owner allows us to change the ownership of it. df allows us to look at the file system. More allows us to see one page at a time. Kill allows us to kill a process, and so on. Okay, so our key files, command files, are actually stored in bin. If we go up to the top and we go into etc. So we can use the pipe at any time. ls, and we can see in here we have a range of files that are usually used to configure the system. So a key file for us is hosts, keeps the mapping of the domain names to IP addresses. And we have the password file, which keeps a list of the user IDs and passwords for the system. Okay, so we can have a look in user. Then within user, we have source. I should find in here that we have our source code, if we have any. And we have lib, user lib, where we have a good deal of our libraries on the system. CG dot takes us up one level. Okay, so we can have in our mount folder, if we have any additional devices, then our CD-ROMs, tape drives and so on will be mounted there. So the Linux security is fairly simple in that we have three types of users, three types of access levels. We have the rights for the user, the rights for their group, and the rights for the rest of the world. So these can be made up of read, write, and execute for each one. So read allows us to be able to read the file, write allows us to write back to it, and X allows us to actually run the file. So an example here is that if we wanted everyone to be able to read, write and execute, we would do change mod 777. So this uses hexadecimal, so a 7 is actually 111, a 6 is 110, and so on. So we can see here that if we want to change it to 766 for read, write, execute, read, write, we would say change mod 766. Okay, so if we maybe want to take an example. So let's go back into full screen again. At any time we can go back to our home folder, our home directory using CD. We'll just check where we are. Okay, so let's do an ls and put it into cat file. Okay, so we should have a file called cat file. Okay, so we can see here it has read write rights for the user, but everyone else can only just read it. If we wanted to give, say, our group write access, so then that will be 6, and we'll keep the write, which is 4, on cat file. And now we can see that's changed it there. We can add and execute to it with 764. And we can even stop ourselves from being able to read it. Okay, so it looks like we don't have permission, so we can change mod it again. And we should now have read-write access. Okay, so that's an example of the attributes Directories have a D attribute at the start, and for the listing we can have a short listing, or we can have a long listing, and it will show us the file attributes, the owner, the group, and the date it was last modified. Okay, so key files are cat, key commands are cat, cd, change mod, cp for copy, history gives us the history of the last so many commands, and ifconfig, which gives us the IP address and networking details of our interface. So we'll just give ifconfig a try. Okay, so this shows us the device name, what its IP address is, what its subnet mask is, what its MAC address is, and so on. So in this case we should be able to ping our own IP address. I can see that works fine. Control C is normally used to quit from a command. So a key file from a security point of view is the password file with inside etc. So this contains the users and the passwords, the current user ID, the group ID that's associated with it, their basic user description, their home directory, and their shell. So the user ID is the first field, followed by a colon, and then we see the password in a hashed or encrypted format. Then we have a user ID. In this case, Fred has a user ID of 508, and he's in the group ID of 9. The description of him is just Fred's, and the home directory is /user2 Fred, and then the shell that he uses is called /bin C shell. So let's have a look at that. Okay, so let's go into the etc. folder, and we will more for password. More gives us one page at a time. Okay, so we can see here are the users on the system. We'll find out more of what this X means in a little minute, but we have a user ID and then a group ID after it. So the ones at the top there are standard users and daemon users that we need for the system. The current user that we are using is here, and we can see that we're user ID 1000 is where the normal user IDs start, and we are group 1000 there. Within the group folder, it contains a list of the actual users on the system. So we can see here, this is a group ID of 1000, and it links to this. A key thing with the password file is that it can be read by anyone. So anyone can come onto the system and actually be able to read this. Unfortunately, the password file can actually be cracked using rainbow tables. So it is obviously a security risk. Okay, so that's the key parameters: username, encrypted password, user ID, group ID, user description, home directory, and shell. When we say a user ID of 0 and a group ID of 0, it means that we have the root account. As we said, the password file is world readable, so anyone can actually read it. So the passwords are typically either MD5 or DES encryption, which is unfortunately limits the password to 8 characters when we use DES. MD5 characters, hashed passwords are 32 characters long, as a hash, MD5 hash should be, and begins with a hash, $sign, and ends with a $sign. And we can use the salt to be able to change the hash file so that password of Fred will always come out, well, will normally come out as a different hashed value. So normally what's done to protect the password file is to use the shadow file. So the shadow file is often where passwords are actually stored now. If we see an X in the password, it means that the actual password is stored inside the shadow file. Okay, so let's recap this again. Have a look to see the problem. Okay, so it's readable by anyone, the whole world in fact. And then when we look at the password file, we should see that we have an X for the users, so that the actual password is stored in the shadow file. So let's have a look at that. And we can see here that the root owns this in the shadow group, so the root can read or write to this. Anyone in the group shadow can read from it, but no one else can. So if we try to list it, because that we are not root, we shouldn't be able to get access to it. So if we want, we can do a sudo, which escalates our privilege up to superuser. And let's cat shadow, and let's look at it one page at a time. And there we go. Okay, so there's the root password at the top there. And we can see here it's between dollars and there is some salt applied. And then we should see our users coming through. So here we go. Here is the password for root, and so on, for the Napier user ID. Okay, so this shadow allows us to protect the password file from attack. On the system, we can normally create C and C++ files. So this is an example of one here. A very simple program. We use VI to be able to create the program. And then we can use the GCC compiler to be able to compile the C code into the actual executable program with the -o option. If we have many C and C++ files, we typically use the /configure command, or we say make, which will build the make file, or make install. Okay, so let's try and build a program. Okay, so I'll just use the VI editor here. I for insert. it's a string called hello, and we'll return 0. This means it's been successful. Escape, colon, work quit. And we should have a file called mynewprog.c. So let's compile it, and the output program will be called mynewprog. And the C file is called mynewprog.c. And that's worked perfectly. Just check to see if we have a program now called that, and there it is, the green one, mynewprog, and hopefully this will say hello. Okay, so we can also use an editor such as Nano, which you might find easier to use. And in this case we do Control X and we say yes to save. This is the file name, and we can recompile, and there we go. Okay, so it's the Linux system is a extremely powerful infrastructure for software development. So some of the tools that we see are similar to what we've seen in other of the units. So in the basic 6 stages for performance reconnaissance, we see things like dumpster diving, social engineering, and so on. For scanning and enumeration, we see the nmap-o, and with RPC, -p, finger, rwho, rusers, and SMTP it can be used to enumerate the devices. In the form of gaining access, then we can have the trivial FTP, and unfortunately the trivial FTP is a fairly easy way to get access to systems as a lightweight FTP server. Then to escalate privileges, we see programs such as PAMSLAM, and then in maintaining access we have rootkits such as Flea, Torm, and Adorm. And then at the end we have the back covering backtracks and placing backdoors. Okay, so let's have a look at an example. So in this case we have two open virtual instances. So the one over here has an address of 192.168.242.24, and let's have a look at the IP address here. So we can see it's 192.168.188.78. So let's ping from this machine to the other one, 242.24. And we can see we can ping it. So now let's do an nmap against that machine. So let's try and discover the operating system and the open ports, 242.24. Just takes a little minute to run, and we can see that we need to run it as root. So let's run it again, 192.168, and it's 242.24. And we can see here it has the open ports of 21, 23, 80, 389 and 5900. And let's go back then. Okay, so we should be able to if we wanted to, we could access the actual server. Quick way is to use Telnet. Or we can use a web browser. So 192.168.242.24. And there we go. We should also be able to FTP into the machine and Telnet 168.242.24. And let's actually create a new file. And then on this machine, let's actually have a look to see if that file's been created. And there it is there. Okay, so we've just telnetted in from this machine into this machine and actually created a file on there. So let's now log out. We should also be able to FTP into it, and we can also remote desktop, because we can actually see that one of the ports that are open is the remote desktop. Port. Okay, so let's look at the remote who and to see if the users that are on the machine. So let's have a look at what the IP address is over here again. And it's 242.24. I could see there are 2 users currently logged in to this machine. We can then use the finger command to be able to look to see how long the user has been on it, what their home directory is, what their shell is, and so on. Okay, so that's some of the commands that we might actually use, or some of the commands that an intruder might use to be able to get into a system. Another security problem that we can have is the RPC, which is the remote procedure call. RPC is used by many systems, such as for remote file access and running remote processes on a system. So obviously an intruder can run remote scripts and commands on a machine using RPC. Okay, so let's look at our 2 systems again. That's one of them. And let's bring up the other one. Okay, so here's our system over here. So we'll have a look at okay, so we can see we have a number of RPC services actually running. We can see the protocols, the basic versions of them. So we have then NFS, which is a remote file system. We have the Mount D, which allows a file system to be remotely mounted. And we also have locks, which allows for locks to be put on files. And there's also a port mapper here. Okay, so over here it's possible to run our RPC info. that. Let's have a look. What the IP address is. Okay, so just to check, so there's nothing running on this machine here. So let's try and connect it to the other machine. And we can see here that we can get access to all the RPC information running on the computer, and it should be just the same as what's running here, and so on. One way to stop an intruder from getting access to a machine is to be able to add it into the hosts.deny file. So let's look at an example of that. Okay, so we'll just check that we can still access it. There we go, so we can access it. So let's have a look at the IP address of this machine. And then we'll go over here, and then we'll deny. So let's use nano, and it's host.deny. Okay, so let's deny this machine access to the services. So now when we try it over here, we're barred from it. Okay, so let's open it up again, go down, and let's delete it here. Quite a useful little program is to suspend. We can control Z anytime. We can see it stopped, and then we can say foreground to bring it back to the foreground again, and there we go, there's them. So we'll now exit and we'll save again, and now everything should be fine. We can have access to RPC info. Okay, so this has given a basic introduction to some of the tools that can be used by an intruder, and also for our pen testing. Okay, so have a look at the textbook and within Network Sims for some of the tests in this area.